Anand, you can go. We're live.
Hello everyone. Welcome to the evening session of day one of Data Privacy Engineering Conference. Today we have a single closing keynote by Paul Vixie. If you don't know who Paul Vixie is, I think you shouldn't be here. So Paul is basically the person who practically did the bind protocol and all the tools around DNS. He's going to give you his opinion about network operations and whether it is relevant in the age of cloud. And he has pretty strong opinions, and I asked him to hold back nothing about whatever he wants to talk about it. So over to you, Paul.
Thank you. So good evening to those of you in India Standard Time. I'm speaking to you from Pacific Standard Time, where it is about 7 o'clock in the morning. And I am thankful to be included in your conference. I do want to correct a couple of things. Yes, I did have a lot to do with Bind. Bind is name server software, and it originally came as part of the BSD Unix operating system, and that was from the University of California at Berkeley. I took over the maintenance of Bind in 1989 when essentially all of the students who had written it graduated and had real jobs. But of course, the internet needed DNS software. I was at that time working for a computer maker called Digital Equipment Corporation. They made VAXs, you may have heard of them. And so that's how I got started with it. So Bind was a couple of years old by the time I took it over. And I did rewrite it, and then I hired a team who rewrote it again. So I probably have had a lot to say about Bind. But really what that has given me is an insight into DNS, the domain name system. And I realize that I'm here today to talk about network operations, but I'm going to use some examples that come from network technology in general. And then I will also cover what I think this means for NetOps. NetOps itself is I don't know, it's an artificial term. The idea that you would use camel case, where you capitalize the N in net and the O in ops, and then slam them together as if they were a word. That really came from the agile community, that idea that you were going to camel case things and make up your own words. And that's unfortunate in some ways, because some of the techniques and technologies that are popular today have been popular for a long time. They just didn't have the names that they have today. And it was not always possible to buy a book or hire a consultant or go to a training that would use those words. And that makes it seem sometimes like innovation is occurring when label engineering is what's occurring. So, let me share my slides. I only have really one slide, so we're going to be staring at this for a while. Let's get started. All right. So we are in the age of cloud. That's inarguable. Very few new data centers are going to be crafted for small to medium-sized companies. It doesn't make economic sense to figure out the power and the cooling and the connectivity and so forth if you are, let's say, a company of 20 employees. What it will make sense to do is to buy VPS, virtual systems, virtual operating systems, a Linux instance, a BSD instance, a Windows instance. It's possible, I suppose, that that somebody will decide they'd like to have a server in their house, in their business. But even in that case, they're probably installing some operating system like VMware or Windows or even Linux in some cases, and then using that server to create the same virtualization agent, the so-called guest operating system. Why do we do it that way? Because to the best of the knowledge of the people in the field now, we've always done it that way. That is that's just the current wisdom. That is the word on the street is, if you want to do this kind of thing, this is how you do it. So I got to say, we didn't always do it that way. It used to be that, for one thing, virtualization is a somewhat modern invention. It's about 20 years old, really, in a real sense. But there was a time when Amazon sold books. They were originally known as Earth's biggest bookstore, and Microsoft sold Windows. Google didn't exist at that point. So in those days, what those companies had to do was build data centers and fill them with computers, and then install whatever operating systems they needed, build their software, test it, and all the rest. And clearly that worked, or we would not have grown as an industry and as an internet to the point where there were some pressures of scale. And ultimately, the way that the legend goes, Amazon built AWS for itself, and then said, gee, this is also going to be a good separate product. In other words, what they needed was a way to have a lot of data centers with a lot of computers, but not have an army of people tending them, and to have a lot of human error creep in. It needed to be elastic in its scale. And so once you've solved that problem, and Amazon ultimately is a logistics company, so they solved that problem, they solved it well. As far as I can tell, they began with the Xen, X-E-N, virtualization platform, which they have since obviously made their own. But if you solve that problem, it's almost a waste if you only use it for yourself. And that's really where the age of cloud began, was because we had pressures of scale. And we can be thankful for that. We have a lot more work getting done, a lot more value being created, a lot more value being exchanged because of, let's say, the internet, than we would have if, let's imagine, everybody was still running Apple Talk, which would really not be able to work at scale outside of the house or the business that was using Apple Talk, or Novell, or any of the other protocol suites that were not the internet. We needed the internet so that we could live this future. And we needed the cloud so that we could live this future. So that sounds rosy. That sounds like an unalloyed good. But I think almost all of you listening to me know that there is really no such thing as an unalloyed good. There's always a price to pay if you want to get some benefit. No such thing as a free lunch, I guess, is what they would say here in the US. So let's talk about food. Let's use that as an example. I really want to illustrate this so that everybody knows not only where we are, but why we are here and why it's inevitable that we had to be here. So 150 years ago, most people in the world, certainly those here in the US, knew where their food came from. And, that didn't mean everybody was growing their own food, although a vastly larger number of people 150 years ago were creating a large part of their own food. But it meant that you knew the person or the farm or the whatever business where your food was made, or if you didn't, you knew how they were doing it. So it was just general knowledge. And so, if you see any of these science fiction dystopias, like Mad Max, Fury Road, wonderful movie, I loved it. In that situation where all of a sudden civilization collapses, you no longer need the benefits of scale, but you also no longer have them. But during the time that you had them, you've created a generation who no longer knows where their food was coming from or how to make it for themselves. They didn't know how it was made. They didn't know what to do. And that is not far from the truth. I realize that it's dystopic fiction in the case of Mad Max, but it's also a real thing. In the 1970s, up until 1980, here in the United States, we didn't really have a diabetes problem. It wasn't an epidemic in the way that it is now. And you can see, if you look at various charts and diagrams that you can find on the web, that in 1980 something changed. That is when the reported cases of diabetes started to rise, and it rose every year. It's a big problem now. What happened? What happened in 1980? What happened is that the US government changed its recommended daily food allowance of what foods you should eat, the so-called food pyramid, how much in grains, how much in meat, how much in fruit. And believe it or not, people listened. I know it's not very common for culture to listen to the governments that it creates, but they did in this case. And it turns out that particular set of recommendations is very heavy on the sugars, the indirect sugars, the carbs, carbohydrates. And so now we have this diabetes problem. I don't think that we could have turned that corner if people knew where their food was coming from. But by that time, it had been over 100 years since the average American knew what food was, how it was made, how it should be made, what you should eat. It used to be common knowledge. Now it is very rare. And so what I'm trying to paint here is the cost, right? It is said that under capitalism, half the world starves and the other half has diabetes. So half the world is getting way too little in calories, and the other half is getting way too much. That does not mean that I am opposed to capitalism. I am a capitalist. I just want to note that capitalism is a magic, and all magic comes at a cost. So yes, under capitalism, half the world starves, the other half has diabetes, but without capitalism, we'd all starve. We could not have the world population that we have creating the value that they create if everybody also had to tend their own farm and grow their own food. We needed both the specialization of labor and the ability to invest capital to create a system. It's remarkable what we let ourselves into under the pressures of scale. And we don't have a lot of food security here in the US right now. We're utterly wedded to the transport chain. Most metropolitan areas are 72 hours away from riots if something happens to that metropolitan area's ability to import food from the parts of the world that are still making it. This should concern us. especially in this time of climate change, political instability. It strikes me that the dependency chain is very long and very fragile and very secret. It's not deliberately secret. It's just, for one thing, impossible to know everything you need to know. The details are too numerous. But for another, the details would only apply to you if you were a gigantic corporation. A corporate person knows how to make food. Real persons generally do not. I realize that in India, you still have a lot of small farmers, and a lot of parts of the country are doing better than what I'm describing here. So I'm giving you kind of the American perspective here. So let me move out of food and out of economics and the pressures of scale and pull some examples from what turns out to be my recent experience. So I had to build a Wi-Fi mesh network for a farm, actually, one of my cousins, and I volunteered to do this. And it did not seem like it was going to be all that difficult. I looked around, I found the right hardware vendors, or I found a possible hardware vendor, did some research, bought some equipment, plugged it in, played with it, configured it kind of on the workbench. Everything looked good. It took me a while. It took me a day or two, but I figured it out. Then I went to the farm in question and deployed it, and things were going well, right? So I put a mesh radio very close to the building that had the internet connection. And then I added another building far away using a Wi-Fi mesh radio, and it worked. And it was fantastic, right? Because this farm is not used to having good internet connectivity. We've got very much a benefit of scale, which is that if you're in a metro area, then it's profitable to build a commercial internet service provider that will serve a lot of houses. But that's because there's density. Without density, we had to have a government program to even get electricity to happen outside of the cities. We called it the Rural Electrification Program. And I'm glad that we do things like that sometimes, but nothing like that has happened for the internet. And so this little Wi-Fi network with its business grade connection was looking good. It was very popular. So I said, great, that's working. That means my fundamental assumptions about how all this is going to work are not wrong. So let's build out the rest. And something strange happened. I added another mesh radio that was actually a little closer to the base station than the first one, and it did not come up. The mesh did not automatically accommodate this new radio. And worse than that, my first connection went down. I no longer had the first working building. I went from 0 to 1, and then when I tried to go to 2, I went back to 0. And I got to tell you, I struggled with this because these things don't have whatever are serial consoles that you can plug into and ask it, what are you seeing? What are you doing? Why are you doing it? No, it's not like that at all. There is a GUI, graphical user interface, and it's ultimately, all of the stuff is based on the Viata. Not this company's products, and all of their competitors are based on the Viata system. So Viata has done some good here. So ultimately, it is a crafted version of Linux, and yes, it has an SSH listener, and you can connect to it if it's on the network. But if it's not, there's no way to connect to it. So you're left with this problem where you don't know how to get started. It's not on the network, and you don't know why. And you can't find out until after it's on the network. So yeah, this was a head scratcher for me. And I eventually found that the way that the mesh protocol in this product seems to work, and I don't know anybody at this company, so I can't really ask them. But the way it seems to work is if somebody's trying to transmit an Ethernet packet and it's to an address that you have not seen, so you have no local forwarding database entry that would say, oh, I know where that MAC address is, so I'm going to use that interface. If you don't have that, and you're supposed to be kind of, I don't know, sending it out as a broadcast so that whoever has that address can answer and say, yeah, I am that person. That only works if you are headed in the direction toward the mesh you have joined. So that just means that if you let the mesh automatically form, then it will be rootless. There will not be some place that has a chance to say, by the way, that's me, unless you're downstream from it. But what happened, and this is borne out by experimental evidence, although I've not looked at the source code, is that my preferred mesh exit point, the thing that had the wired connection to the internet, was joining a mesh, and therefore it was willing to transmit packets upstream toward the mesh it had joined, but that mesh was not willing to transmit packets downstream toward this outside connection. So I laboriously took every one of these radios off of its building, because they were all by that time, up on the roof and so forth. I took every one of them and I plugged them back in and reconfigured them to say, look, I don't want you to automate your mesh. I want you to choose exactly who you could potentially talk to. And so I made my own topology using static configuration. I just turned off all the automation, and it worked perfectly. So what does that mean? It means that if you weren't building networks before the age of cloud, and you buy this product, hoping that you're going to be able to, let's say, build the network you need and the one they're advertising as being available, you might be very frustrated. And you're not going to get this solved with the documentation. You're not going to get this solved with tech support. And you don't have either the knowledge or the serial consoles that it would take to sort of diagnose this, right? I was very much kind of shooting in the dark, hoping to hit something, and I eventually guessed right. But I had to know what to guess, which meant I had to know how the ARP protocol works, ARP, Address Resolution Protocol. I had to know sort of what is an Ethernet broadcast packet, what is an Ethernet multicast packet, how does IP version 4 use this? And I don't think most of the customers who buy this equipment have any clue about those things. And if you don't know what the opportunities were, what roads were not taken by your manufacturer, and you're just a prisoner of their GUI, you might end up as a very dissatisfied customer returning all the equipment that you bought because it doesn't automatically do everything that it's supposed to automatically do. So, in that sense, it was lucky that I have been using computers since before Ethernet was available. And so I know what alternatives existed for Ethernet itself, let alone all of the technologies that have come since. I'm going to come back to Ethernet in a moment, but I also want to talk a little bit about IPv6. And I'll use this same mesh network as my example. When the internet connection was installed, the ISP said, by the way, here's your address. It was a business grade connection, so they were not going to use DHCP toward me. They said, here's your address, here's the subnet, here's our address. You can set your default route to point at our address, and everything will work fine. And it did, and that was all great. But after we got this whole thing running, I said, gee, since you also delivered IPv6, and since, you know, there may be a need for that someday, I'm going to also get that working. And it didn't work. And luckily, by this time, my little Viata-based router was on network, and I was able to SSH into it so that I could find out, you know, what's going on here. And I think all of you are familiar with the IP command. I'm not a Linux lover. I'm still learning this. I'm still using BSD for most of my work, but this is how the rest of the world works, and I got to learn it. I'm not resentful. But anyway, I looked around and I found my router didn't have a default route, so there's a for v6, so that was a problem. But I thought, you know, before I go there, let me make sure that I can at least do IPv6 neighbor discovery on the next hop that I was given. I was told where to point my default route. Let's try to ping that, shall we? No answer. Okay, well, let's mess around a little longer and see, do we have an IPv6 neighbor discovery result, which is that's what they call ARP for IPv6. You send a broadcast packet containing the v6 address that you'd like to talk to, and the person who has that address answers you and says, I have that address. Here is my Ethernet MAC address. If you wanted to send me packet, you wanted to send packets to that IPv6 address, here's your Ethernet address to do that with. But that failed also. That was not working. And so I reported this duly to the ISP, and I said, hey, you know, v6 is not working. And they said, well, they didn't speak these words, but the thing that they said boiled down to, well, we don't really work at the level of typing commands at routers anymore. We have a GUI. I am your installation engineer, and it all looks good here. Okay. And so I sent, you know, some results. I did what we all do. I copy pasted, and I said, this is what I'm trying. This is what's happening. This is what I'm getting. This is the state of my router. And, you know, and in the next round, that particular engineer, who, by the way, is brilliant, but he's shackled by the fact that he can't touch his own router. He's stuck with his provisioning GUI. You know, he said, well, you know, I really think that you should, you know, don't try and ping us. We might not answer. We might have blocked ICMP. So, you know, just try to reach the open internet. Everything will be fine. And I had to explain to him, that's not going to work, because I don't, since I can't ping or otherwise reach, there's no IPv6 neighbor discovery, or IPv6 ARP if you prefer. There's no result of that in my router, so it will not be able to reach anything until it knows what Ethernet address to put on the packets that it wants to send to the rest of the internet through you and your router. And that was a head scratcher for him. I gave him the RFC number for IPv6 neighbor discovery. And I gave him the new one, not the old one. Hasn't changed much. And he appreciated that. And he said, you know, I will research this. He could tell that we didn't know enough. He and I together didn't know enough. But I am lucky in his case that he actually understood the results of the commands I was running. A generation from now, he will not. His successor, if any of his kids go into the same business that he's in, they will not know what the IP command does. And so I'm lucky that I'm kind of on this cusp of generations. This should also concern us the same way that food security concerns us. So I promised I'd come back to Ethernet, and there are many stories I could tell, but I'm going to stick to just one, which is the MTU, the maximum transmission unit. This is the size of the largest packet that you can carry on some network link. Now, we often incorporate this concept into broader ideas. So we have something now called PMTU, which is the path MTU. And what that is for a given destination, there's a set of networks that you have to traverse between where you are and where they are. And one of them is going to have an MTU, a link MTU, that is the smallest one. And in practical terms, they are all 1500 because that's what Ethernet offers. And everything kind of looks like Ethernet, even if it isn't. It's just so convenient to pretend everything is an Ethernet that we've now got all kinds of things that use this same concept. But 1500 is the MTU you're going to see. So let me set the Wayback Machine for the early 90s when the ATM protocol was being developed. This is back when the internet was still in a fight. There was still a protocol suite called OSI that had its own version, its own equivalent of TCP. It was called TP4. And there were a lot of European telephone companies who'd made a lot of investment. In fact, my employer, Digital Equipment Corporation, spent, probably $1 billion on making a really nice OSI protocol suite because they thought that was going to be the future of communications. It wasn't. They should have spent that money on internet. They might still exist today if they had spent that money on internet. So they guessed wrong. But anyway, the ATM people were part of the OSI crowd. Yeah, so there were a lot of telephone company people, a lot of people from the ITU, the International Telegraphy Union, were saying, this is what we need. It wasn't what we needed, and you're not going to find very many ATM links today, other than hidden behind DSL, where it kind of still exists. What we ended up with is packet on sonnet as our common link. But one of the reasons that ATM failed in the marketplace was because of their cell size. Everything had to fit in a 53-byte cell. And every one of those had a 5-byte header to tell the receiver of a given cell where it was going. And so you had all this complexity in the network where you were trying to, so every endpoint had to ask its local router essentially to make a phone call. Please build me a virtual circuit to a certain place because I want to send ATM cells and I need everything between me and it to recognize and properly route those cells. And this worked on the whiteboard. But at OC3C speeds, which was 155 megabits, which I know seems slow to you today listening to me, but trust me, in 1994, that was a lot of bits, 155 megabits. But the problem is that building microelectronics that could handle cell switching at OC3 speeds was an expensive problem. Took a lot of transistors, a lot of watts of power. And it just turned out we need bigger packets, essentially, so that the microelectronics doesn't have to make so many decisions per second. We have to cut down the number of decisions per second. And so there was Ethernet, 1500 bytes, much bigger than 53. So you could build cheaper routing equipment and switching equipment if you made everything look like Ethernet or packet on sonnet or anything that where the number of routing decisions and switching decisions per second was small enough to fit in the envelope of what could be built at scale. So here again, we see the pressures of scale leading us away from this sort of unscalable technology. Okay, so I got to do some math with you. On 10 megabit Ethernet, the original Ethernet protocol, if you sent minimum sized, which was about 60 bytes, minimum spaced, right? There's no distance between one packet and another other than what Ethernet requires for its trailers and headers and whatever. So minimum spaced, minimum sized packets, and you just send those as fast as you can. You're going to get about 14,000 of them per second. Now that was a lot in the early 80s. It meant that you weren't going to be making those decisions with your CPU. You needed your Ethernet interface to be able to recognize the relatively small number of those packets that could be destined for you and ignore everything else. And it was very cool and it worked. But 14,000 became a fairly practical number. That's why we had so many switches and routers and host-based routers and all the rest. Okay, well, let's talking about MTU here. 1,500 compared to 14,000. It compares well. Obviously, 1,500 is not a minimum size packet. So if you have the maximum size packet, you're probably only dealing with 1,000 of them per second. And that's really practical, even in 1986. So here's the problem. We sped it up. We made Ethernet faster. We got fast Ethernet, 100 megabit. Then we got gigabit Ethernet. Then we got 10 gigabit Ethernet, 40 gigabit Ethernet, 100 gigabit Ethernet. We keep on making it faster because that's the pressure of scale. It's the opportunity to make things faster and do more things with the same number of transistors. And the problem is we never changed the MTU. The MTU is still 1,500. And the reason we had to do that is every new version of Ethernet has to be compatible with the current installed base. So when we got fast Ethernet, it was 10 times faster at the bit level, but we had to be able to make a bridge between the fast Ethernet and these, at that time, slow original 10 megabit Ethernet. Because if we said, yeah, here's a new version of Ethernet, by the way, you're going to need a forklift because you got to tear out everything you own and replace it with this, fast Ethernet would have failed in the market. So they said, no, we're just going to stick with this 1,500 and deal with whatever, 140,000 packets per second if they're all tiny instead of 14,000. And we did that every time. And so at 10 gigabit Ethernet, I got to tell you that the number of routing decisions we're making per second is absurdly higher than what it was for ATM on OC3C. And we're just lucky that transistors are cheaper now, but we're burning a lot of heat. And NVIDIA bought a company recently that has a line card that offers to speak these protocol, like the IP version 6, whatever. It'll speak that protocol for you in its own operating system using its own CPU, which is on the line card, because there's no way, we're back to the time that there's simply no way that a CPU could tolerate the load of that many decisions per second. So we end up with a coprocessor on the line card. That's a lot of complexity. That's a lot of vulnerabilities that we don't know about yet, bugs. There's a lot that's going to go on there because we never changed the MTU. So again, we have a pressure of scale, and it has created this MTU problem. And I got to tell you, when half of you right now are scratching your heads because you've never had to think about an MTU before. And it never occurred to you that we had alternatives, that there were other roads and that those roads weren't taken. And you don't know not only what road wasn't taken, but why you yourself would not have taken that road had it been up to you. And the reason for that is there's mostly not a reason for about half of you, statistically speaking, to have ever had to innovate at this level. You just use what is built and build your thing on top of that so that your company can succeed, and so that we can all continue to get paychecks. And that is why the MTU never changes, is that there's no reason for anybody who wasn't working in the industry before Ethernet came along in the first place. If you haven't been doing it that long, you don't know what an MTU is. You don't know that there were design choices about what to use. So I got to tell you, on my networks, we use mobigrams. I've told all the switchgear to allow up to 9,100 bytes. And that works as long as you have a way to know which hosts you can reach at that size versus which ones you can't. And again, this calls for understanding how a routing table works, knowing what path MTU is, knowing what path MTU discovery is, And if you do that, I hope to inspire some of you to go build a test network, use the NFS protocol, network file system, tell it to use both, try this under both UDP and TCP, tell it to use 8 kilobyte payloads and run some performance tests on both a standard 1500 byte MTU and on a 9100 byte MTU that allows 8K packets. I think you'll be shocked about the roads the world did not take without understanding that those choices were ever open to them, or that they could have chosen a different road. Some of you who do that are going to end up using mobigrams inside your companies, inside your houses, for the same reasons I do. But again, this is not something that they teach in school, or if they do, it's sort of like Latin. Yeah, they teach it. I learned it. That does not mean that I'm ever going to need to know this for the rest of my life. And so you forget it right away. So when I was preparing to get on this Zoom call, I discovered that my Lenovo laptop running the Windows 10 operating system had decided to, I guess, scan itself. I guess it does that from time to time. And it saw that there was some device driver that really, there was a later version available, so let's install that. And what that meant is that my audio broke, because the Realtek chip is finicky. And that is the thing we all use for the headphone jack on our laptop. Probably, I don't know if this for a fact, but probably even a Macintosh is using a Realtek chip for that, because it's what everybody does. But certainly on Windows, the Realtek driver doesn't work all that well. And you really need to get into the device manager and delete the wrong driver and switch to the right driver and all the rest of that. And I guess it's lucky for me that I have faced this debacle before and I knew what to do. And that allows me to speak to you today, because otherwise that would not be happening. That should concern us, because most Windows users and all Macintosh users have no idea what that issue is. And you could argue that maybe Microsoft should do a better job with their device manager, or that Lenovo should do a better job on their software updates. And that's possibly so. But we're getting back to the mesh radio thing, which is, you may be having a problem that you're completely unequipped to understand. You could end up potentially tying up many hours of some tech support person's time on something it's an integration failure. And yes, Lenovo and Microsoft could probably do better, but they won't make more money, nor will their customers make or save more money as a result of that investment. So that investment will not be made. So you can say of things that scale that nothing will ever be built at scale better than it has to be. In other words, if you're inside the bell curve, you're good enough. And once it's good enough, you ship it and you get on to the next thing. And again, I'm okay with this. I know what choices they had. I know what choices I have. And I understand enough about what's going on here that I know how to fix it. My descendants, I have 4 children. My youngest just turned 30. They do not understand these issues. So if you invite them, one of them or one of that generation, to speak to this conference 25 years from now, they may not know as much about how their technology works as I did. So this all sort of comes back to first world problems. The Internet Engineering Task Force, IETF, is where all of these protocols come from. It's where TCP comes from, IP version 6, UDP, DNS, all that sort of thing is done in this. It's an all-volunteer organization. It has like 5 employees who have the job of holding conferences where all the volunteers go, and they argue and they whiteboard and they present and they write internet drafts that ultimately become RFC documents, which are Internet Protocol standards. This is not working very well. We have too many volunteers, and they have too many different agendas, and those agendas are often ruled by their employers. Why does that matter, right? Because the people who participate are doing so as individuals. But somebody has to pay for their airplane ticket to go to this conference. Somebody has to pay their salary while they spend all day arguing on internet mailing lists about the whichness of what, as to what protocol should be next and how that protocol should work and what its features should be. And so these volunteers have backers. There's no way to do this if you don't have a backer. You can't keep up. You can't afford the travel. You can't afford the time. So ultimately, it is corporate persons, not real persons, but corporate persons who dictate what standards are created and what features those standards will have. This is very much a wealth gap, is what it means. As I travel the world, I talk to people who, in their wildest dreams, will never be able to afford an airplane ticket to go to even one IETF meeting, let alone 3 per year. And they might be on a mailing list or two, they might not, but chances are low that somebody I meet in my travels is able to affect their own future by participating in this open, transparent, nonprofit standards process. They just can't. Even I can't, right? And I'm the CEO of my company. I could tell myself to behave differently and allocate my time differently, but that's not the best use of my time. And if people at my level of seniority can't afford to participate, that pretty much means that the companies who can afford to hire the best people and send them in there are going to be setting the agenda for the internet going forward. And one of the ways they're doing that is by moving DNS sort of into the web. They're pushing the DNS protocol to start using the HTTPS protocol, so secure web transaction based on TLS. They've also revised TLS, so version 1.3 of TLS now is firewall proof. So any of us who have a next-gen firewall that relies on intercepting an outbound connection, pretending to be the far end, getting one of our own devices to then tell us what it wants to do so that we can make a policy decision about whether to allow it or not, that's going away because the IETF has willed it so. So the idea of a secure private network is not represented. Why is that? Well, it's because the people who operate those networks are busy and they are not going to go to an IETF meeting and argue for what they need. Whereas the cell phone makers, they are present. Browser makers, they are present. Surveillance capitalists, big tech, they are present. So we're going to move more of the internet protocol into a pattern that will make ad blockers impossible. And it turns out that there's an odd coincidence that the companies who are employing and funding the IETF members who are pushing for this all make money from ads. And so now we're going to have something that is ad blocker proof. Now, they're not selling it that way. What they're saying is, gee, look what Edward Snowden disclosed in 2013. Look at government surveillance. Look at how terrible governments are. We need to make the internet totally encrypted so that governments cannot interfere with the communication of their citizens. Okay, well, I got to tell you, there are countries in the world. India is right next to China, so China would be an example that would be close to home for this audience, that don't really want their citizens to, let's say, talk about Taiwan or talk about Tiananmen Square or whatever. And they got one party rule. And China's not alone. Russia's doing something similar. Turkey is doing something similar. Obviously, North Korea would be an example of citizens not having a lot of rights. There are countries around the world who are not waiting to hear what the IETF has in store for them. And they will do whatever they have to do to maintain the old status quo. And so the idea of a bunch of plucky volunteers whose bosses are happy that ad blockers will become impossible, that they themselves have a idealistic mission of making sure that communication is government proof. This is not working. It's not going to work. It's going to lead to chaos. But that, again, is the pressure of scale. Since the people who need to be represented can't afford to be represented, they aren't. And so we're getting whatever protocol the 20-somethings of Silicon Valley want us to have. That's not going to be good. So in the future, what can be done to mitigate this? I would say that there's something that each of us has to do that makes no economic sense in the short term. And that is that we have to build something better than it has to be built. And that something is ourselves. We have to tinker. We have to, once in a while, look at the assembly code generated by the compilers we use for our programming to find out what's going on down there. Because it may be that you need to make some different choices that you won't be able to make if you don't know what an instruction is or what a register is. The future of all these things, of food, internet protocols, CPU design, operating systems, everything about our future is going to be very heavily dictated by technology. So this is not just the age of the cloud. We are in the information age, and information is power. Information creates wealth. And the people who understand information and understand information technology are going to be the ones that kind of decide what our future is. And I want that to be all of us. So I want to encourage companies, governments, and especially you, individual technologists within the sound of my voice, to learn things that your job does not require. Find out the history of why things are the way they are. Don't just buy a bunch of Raspberry Pis to build your home lab, plug them all in, and run a bunch of binary packages that will cause them to behave as a virtual cloud. Look at the source code of those packages. Educate yourself on things that you have no earthly reason to know, but if you know them, there's a chance that you will make some decisions that will be informed by your experiences, your needs, your plans, rather than have your future dictated to you by the relatively small and shrinking fraction of the world who actually knows how any of this works. Be one of those people. And that's what I came here to say. So I don't know if I have any time for, I mean, I'm just sitting here, but I don't know if I'm going to be allowed to answer questions or not, but I throw it back to the moderator. Oh, and let me just say, thank you again for inviting me. These topics are vital to me. I want my children and their children after I'm gone to have a world that is democratic and transparent, where freedom matters, and decisions that we make matter. And it's not all just sort of this pleasant veneer of technology that where we're being led where the technology leaders want us to go. I really want you to listen. I'm not here to sell you anything other than yourselves. I'm here to sell you a better future. So again, thank you for having me.
All right. We're now open for questions. People who are on Zoom call can paste their questions on the Q&A tab, and I will just basically read it out to Paul, and he could answer going forward. And if there are no questions, I may probably sneak in a few of mine. Jyotsna, 1 minute. Are we copy pasting questions from Twitter from the live stream or no? Manish?
I will.
Rashwin, are we copy pasting questions from the YouTube live stream or no?
No, the chat is not enabled.
Okay, fair enough. So questions, anyone? Whoever is on the Zoom call? Okay, we have a few questions. Okay. The first one is from Sumankar. He asks, you have made it clear that DNS over HTTPS presents some challenges for enterprises. Have you changed your positions since the last RSA conference? Paul, you're on mute.
Yeah, I've unmuted. Thank you. I think I have refined my position, but as things are rolling out, I'm seeing a growing concern. So if you've heard me talk about DOH, then I'm probably more panicked now than I was when you last heard me talk about it. The IETF is moving some parts of the DNS protocol not only into the web for transport, but into web pages. So we will shortly see meta tags in our HTML objects that contain the DNS bindings necessary to fetch all of the rest of the object. So if you've got a page that includes maybe some style sheets and some graphical files or JavaScript, rather than hear those references in the browser and then have to make a DNS request to find out, well, where is that being served from? You're going to get all of those bindings as part of the containing object, so you won't be making those other queries. And that means that any of us who kind of depend on knowing the behavior of the devices on our network, and therefore saying, hey, if you're fetching this, if you're trying to reach that host, you've probably been infected with some virus or whatever. We're not going to see the fetches because there will be no questions. The answers will be delivered as part of the web content itself. And this is because there's no one working on the web who is also trying to secure the web or secure the internet. So if anything, I'm even more hardened in my positions than I was when I spoke at the RSA.
Suman, do you have any follow-up questions? Can you just please paste them? Okay, and he says, Suman, this sounds ominous for home users who do not have the tech know-how or the budget to even identify these challenges. Is that right?
Well, it is. And, I think we all know that those of us with jobs in the tech sector might not have those jobs if the internet weren't growing. And as it grows, we're going to reach more and more parts of the world where no technologist lives in that apartment or in that house. And so those people are going to be at the mercy of their supply chain. So this is a big problem, but there's actually other big problems that are also being ignored. And so I guess that means we are going to ignore them all. But to give you an example, think about the Internet of Things, IoT. We're seeing a lot of home appliances like refrigerators or laundry equipment or heaters, air conditioners, whatever. They all want to be on net. They all want to be controllable by your cell phone. And importantly, they all want to communicate with their mothership back at their corporation of manufacture. They want to say, by the way, this is how much laundry is done in this house. If it's a little Roomba robot to go sweep your floors, it wants to report back to its maker how big your rooms are. And even if you can make money on laundry equipment, you don't make more money by adding this IoT logic to it. So all of the investment that is going into IoT is not so that they can create, let's say, a light bulb that you can change the color with your cell phone. They want the data. They want to know when you turn that light on and when you turn it off. Because if they can learn that about you, they can sell that information. And somebody somewhere will have a better time advertising some product to you because of all of the IoT data that has been pulled out of your house. So surveillance capitalism is not just big tech, it's also small tech. No IoT technology is ever going to be profitable from its own manufacture and distribution. All of the profits from all investment in IoT comes from surveillance. And so, yeah, you should worry about DOH, but you should also worry about that Nest thermostat you've got there. Did you know it had a microphone? Yeah, Google, when they owned Nest, said, gee, sorry, we didn't tell you there was a microphone, but we've never used it, I promise. Okay, that's great, but I've also got a baby monitor, a camera, watching my baby sleep at night that is participating in DDoSes because it's got vulnerabilities. How do I know that the microphone that's in that Nest thermostat hasn't been abused by some malicious software that got into it? So we've already crossed into dangerous territory just by building the network we have and trying to grow it as we have. And so, yes, what I'm saying is ominous, and I intend it to be. I'm not here to tell you that everything's going to be fine, because unless those of you listening to me take action, everything's not going to be fine. But I also just want to say a lot of damage is already done. And, we heard last week about something called NameWreck, where the supply chain for DNS software has some terrible vulnerabilities in it. And I'm responsible for that. This was originally the bind software libraries that came from UC Berkeley that I was publishing, that as recently as 1998 had these vulnerabilities. We fixed them, but the supply chain had copied my software earlier than that, never checked back with us, and has now incorporated DNS libraries with known vulnerabilities without any idea of how they would know which cert advisory applies to them, without any idea about what the bugs are, how they would go about updating that supply chain. Nobody knows. The companies who make the devices that are vulnerable are not in on it. They themselves are victims of the pressures of scale. And so, yes, I want you to worry. I'm telling you some bad news. And some of that isn't news. So I'm telling you some bad things that used to be news.
Okay. Last question from Suman. So will it be wise to regulate and outright ban certain products like, say, smart tampons?
I'm sorry, can you repeat the question?
He says, so would it be wise to regulate and outright ban certain products like, say, smart tampons?
So would it be wise to regulate is kind of a trigger question. There are a lot of self-styled internet libertarians who always answer no to any question that has the word regulation in it. I am not of that view. I think that Underwriters Laboratory did some vital work in the early days of electricity by saying, yeah, we're willing to test your whatever toaster. Let's say you had a device for toasting bread. It's going to get plugged into the electrical socket in some house. We are willing, Underwriters Laboratory is willing to take that toaster and try it ourselves, and I don't know, drop it in a tub of water, see if it electrocutes people, whatever it is, whatever testing they did, safety testing. And that gave the people who were adopting electrical appliances an opportunity to pick the one that would not burn their house down, or at least that Underwriters Laboratories said that we tested it, we don't think it's going to burn your house down, instead of buying one that did not have that certification. And the power of governments would be to say, you can't sell something that does not have that certification. Or maybe government, as the largest information technology buyer in most economies, can simply say, we are not going to buy anything that doesn't have that certification. Therefore, it will fail in the market, because if the government buys 0 instances of that product, it doesn't matter who else does or doesn't buy it. So government has a role here. But I'm cautious about recommending activities by government because government is historically fickle. Every time you have an election, there's a chance that the government's priorities are going to change. And it's also notoriously inefficient. We have a lot of people in government whose job is very narrow, and we don't really want them thinking outside the box. Just like we don't want our medical doctors doing real science. We don't want to be the subject of an experiment. We want to be cured. So when it comes to government regulation, I would say there should be a lot more concern than there is, but I don't want to make it sound like the government is capable of understanding these issues and keeping us safe. And this is the last question. Let me close with this observation. Governments are very good at securing physical borders. That is, in some sense, the reason every government exists is to make sure that the borders stay where they are. And what that means is if you have a neighboring country who, I don't know, maybe they'd like to fly an airplane over one of your cities and drop a bomb, yeah, your government's going to be able to keep that from happening. That's what they do. That's why governments exist. But if the same country wants to attack the same city with a cyber attack, they want to, just kind of reach for you over the tubes and steal your information, or maybe inject bad information, or maybe inject disinformation into your elections. That's happening here in the US right now. For whatever reason, Russia has chosen to take a hand in the last couple of elections here. Your government can't stop that. The information technology moves too quickly, and the government will never be able to secure the borders of cyberspace. That is going to be up to everybody who connects anything to any network. And that means it's an unsolvable problem because most people will never understand the issues. They're counting on their supply chain. Their supply chain has the pressures of scale, so those people are going to be vulnerable. That means the people at this conference have got to scale as well, as at least as quickly as the problem is scaling. So there's a difference that you here within the sound of my voice can make. And government should also take some action, but I don't want us to trust that government can solve this problem. It's us. This is on us now.
There are more questions. The previous comment about being the last question was only for that particular person.
Oh, okay. All right.
Right. So we have a related question from Preetham, who says, Paul, any resources that helped you to understand our history in a better way, which can help us who are starting this journey?
So I did not make a third slide that would be a call to action with a bunch of links that you could follow. And the reason is it's going to be different for each one of you. So there's certainly, if you just look at the technology in any device that you have, let's say you've got a Raspberry Pi or you've got a laptop, whatever, you should find out what software it has and where that software came from. You should look on GitHub to see what software like that usually does. I wrote the version of cron, which is in virtually all BSD and most Linux systems, and also in Mac OS. And if you want to learn how to make Unix system calls to create subprocesses and manage pipes, then you can look at my software. And a lot of things that are in your life today, in the lives of all of us today, came from the open source world. Even if sometimes the software is out of date and has vulnerabilities, it originally came from something that probably has been patched. And it's worth looking at the history of some of the open source software that is in the devices in your pocket and find out how it works. And maybe, consider downloading it, figuring out how to build it, and see if you can add a feature. And I don't mean you're going to add a feature and then try to upstream it, although some of you have and others will. I just mean, see if you can familiarize yourself with what are the opportunities of a developer of software like that. What roads do they have to choose between and how will they choose? And you can also look at the network protocols that are spoken by all of these things. There's a new version of SSH out right now that is finally ready to talk to my YubiKey. And I plan to read about the entire value chain that made that possible, and find out which software has been audited by whom, so that I can decide how much confidence I should place in that new feature. And all of you can do that. You don't need specific pointers from me to tell you, gee, you should probably look at this and look at that. Although if you wanted to join an IETF mailing list and just watch the discussions, that's another way to get yourself involved, because it's going to take a while to get yourself up to speed to the point where your judgment can make a difference in the outcome for all of us. And so the universal thing, no matter how you got here or where you intend to go next, the universal recommendation is the same. Learn more than you need to know, because in the future, you will have needed to know it.
Okay. The next question comes from Lava Kumar. He asks, what is your prediction for the open web in the age where big companies have incentives to create walled gardens like the App Store and the Play Store?
Well, the web has been mostly open, and there are some problems. And I'll come to the App Store question in a moment, but I call your attention to HTTP version 3, which is based on the UDP protocol instead of on the TCP protocol. Now, HTTP 3 uses TLS, and we're already using TLS. And so TLS is not the new element here. But what TLS has meant is that it's very difficult to inspect payloads. You can't really do deep packet inspection successfully if the data has been encrypted with TLS. And it used to be at least theoretically possible to do that with TLS 1.1, TLS 1.2. However, in TLS 1.3, with encrypted client hello, there will be no opportunity. So as that rolls out, a lot of us are going to get blind to what is the behavior of the devices on our network, which is sad because we're going to get blamed for any spam we relay. We're going to get blamed for any DDoSes we join. So our network is becoming something that we are responsible for, or how it behaves, but we are not permitted by the IETF to know why it behaves that way. And that's a problem. And in the HTTP 3 protocol, when we move from TCP to UDP, we're also going to move all of the congestion control logic out of the kernel and into the app. So how you behave in terms of whether it's TCP Prague or TCP Budapest or whatever is no longer up to the maker of your operating system. It's going to be up to the maker of your app. And maybe it's got an up-to-date copy of some protocol suite, maybe it doesn't. If it's vulnerable, who knows? We've made the supply chain deeper and broader. That's never a good thing for security. But the thing I want to focus your attention on is that right now, if my browser wants to reach out and grab a web page, it has to ask the kernel to create a TCP session. And that's a system call. And it doesn't matter whether it's Windows or Android or Mac OS or Linux, BSD, they all work the same way, which is first the app asks the operating system to please make me a connection. And then it asks the operating system, please transmit the following data, which might be a TLS handshake or might be a request, whatever. But in the HTTP 3, that goes away. There is no system call that by which an app has to ask the operating system to please make a connection somewhere. And that in turn means that anything we had that was inspecting, monitoring the app to see if the behavior was correct, no longer has the ability to say, look, you're trying to connect to something. You have asked me to make a TCP session to a destination that I know has only malicious purposes. So I am going to reject that. I'm going to cause your TCP connection attempt to fail. And that's something the operating system can do. It can have policy and it can enforce the policy. You can also put that app under a debugger, and you can start to say, first it did this, then it did that. Maybe you've got a sandbox and you collect malware samples and you run them in the sandbox. And you're really depending on being able to find out what is the behavior of a piece of malware. All of that disappears once we move from TCP to UDP. And so I think the problems from the open web are much larger than just what will happen in the app stores. But I want to answer the app store question also. I have an Android phone and I can install any app I want. There's a little checkbox in the settings. So I don't have to get everything from a certain app store. If the Amazon Android app store has something I want, I can install it. And that's freedom that the Android team over at Google has decided I should have. Apple has made a different decision. You can only get apps from them, or if you're a developer, you can get an app over a USB cord or a Bluetooth connection, but there will be no apps running on Apple's devices that did not get approved by Apple. This should concern us, because while, let's say, the Firefox or Brave browser on every other platform is responsible for its own connection management, in the Apple world, they won't permit you to do that. So those browsers all use, I believe, the JavaScript engine and the connection management framework that is in the iOS platform. And so the browsers may look different, but they're all kind of the same engine, different car. And that's a decision Apple made. And Apple is capable of making other decisions. There was a period where they were permitting their own apps, the things that come with the operating system on the Mac OS, they were permitting those to bypass the firewall, because they went directly down into the Mach kernel and they just bypassed whatever kind of firewall the Mac seemed to have. Wait, all of my Apple apps are getting out, even though I've got a firewall that should block that. Well, that's Apple. Apple explained, look, we need to have a good user experience. We can't let your firewall get in the way of that. Okay. Now they reversed that choice. They said, yeah, we kind of understand why you might want to have a firewall. And so we will, by our own policy, volunteer to be subject to your firewall on the device you bought that we still control. We're going to let your device do one more thing for you. But that's a choice we, Apple, are making. That means Apple can revise that choice at any time. So it's not just that you can't get your apps from anybody but Apple, and that you're therefore only going to get the apps that don't threaten Apple's market dominance. You also have Apple deciding exactly in detail how your device, the one you paid for, that's on your network, is going to behave. I was listening in on an IETF conversation about HTTP3, and somebody from Apple said, yeah, we can't do that. I don't know what the feature was. There was some protocol knob somebody was saying, we should do it this way. And Apple said, well, we, Apple, can't do it that way because we've got multiple things. We've got a radio that speaks to LTE, the mobile network, and we also have the radio that speaks to the local Wi-Fi. And we use both at all times. We are, so some of the things we do, like media streams, we're going to choose one. Others, control streams, we'll choose the other. And that worries me, because it matters what signal we transmit from the devices that we carry, and it matters who's able to see them. There's a huge amount of geographic location information about all of us. It's being uplinked by all the apps on our phone. So if you like, this a Pokemon game. If you like that kind of thing, then be aware they're not making any money from you playing their game. They're making their money from selling your location, which they have access to whenever that game is running. But there are a lot of worries about the openness going away. And so here I'll give you a historical perspective. The internet had something that the OSI protocol suite did not have. And that was that it was organically developed by the tech community. And this is before there was an internet, therefore there were no search engines or anything else. This was the tech community, pre-commercial, had some goals, and they built some things that worked that way. And I guess Berkeley Unix was the first one to have TCP/IP, but then Linux came along and also adopted it. And it just turned out you could get more better work done with that than with any of the OSI stuff. However, the reason that all of that was possible is that we had permission to innovate. We had the freedom to innovate. So when, let's say, the web came along, they said, hey, there's this thing called the internet, and it's a way for anybody to exchange digital data with anybody else. What can we build on a framework like that? And they did. They used TCP, they used DNS, they used, a lot of internet technologies to build the web. And that's because the internet at that time was designed to give you the freedom to innovate. You didn't need to ask any phone company whether you could build something like the web. Whereas in the OSI protocol suite, you would have had to get the phone companies to think that this was in their best interests. So what have they done? What has big tech done? What has the web industry done with that freedom to innovate? Well, clearly they've got a global e-commerce and communications platform that is very relevant, very influential. But the other thing that they're doing is making sure that that freedom to innovate, therefore the freedom to disrupt, is no longer present. So they've climbed a ladder, and now they're pulling that ladder up behind them. You can resist this, but it will come as some cost to you. You'll be getting complaints, as I do, from my family about the things that our network refuses to do. If you're willing to live with those complaints, you can keep that ladder from being fully pulled up. But step one, I'm going to go back to my original message. Step one is you have to understand how this works. You have to know how stuff works. You have to know more than you need to know for your job. And that, again, that's the same is true of network operations. Don't become that person who only understands the GUI. Go learn what that router is trying to do. Yeah, you may never have to configure a BGP session by hand. There's some automation that'll do that, but you need to know what the automation is doing and what the choices were and why they made the choices they made.
Cool. We have a last question, and then after that, we're done, I think.
Okay.
This is from Lava Kumar. He says, what impact do you think the deplatforming of the US president had? Will some digital rights and freedom be made fundamental rights?
We're already having wide disparity in rights. So if you consider the parts of the world where government is very weak, you see a lot of really terrible things happening. And here I'm thinking about human trafficking, but you could pick whatever example is the one you most worry about. And when government is too strong, like let's say North Korea is a traditional example, you get different abuses, right? There's an ideal set of rights and an ideal sort of extent of the government's ability to protect and recognize those rights. There's a Goldilocks zone. There is a middle ground there that works. And one of the reasons I've always been ready to come to India, I realize I'm only here virtually right now, but one of the reasons I agreed to speak at a couple of different conferences in recent years and would accept an opportunity once I'm allowed to travel and the pandemic is behind us, is because India, I'm sure those of you who live there have got complaints, but I got to say, compared to the rest of the world, India is in the Goldilocks zone of what rights are recognized by government and how well the government is able to enforce those rights. I'm not saying there aren't problems, and if I lived there, I'd know enough about those problems to complain about it. I just want to say that India has been a shining example about how to find the Goldilocks zone and mostly stay within it. Most other countries don't do as well. So it won't really matter what rights the technologists building the next gen internet or the next gen web want to have recognized. What will matter is local power, right? There's a reason we have nations. And if you want to know, if you want to see this reason in action, just go pick some square kilometer of ground somewhere and put it outside of any nation. You'll find that some nation has quickly annexed it. We've got a lot of people who think that nations are not the ones who should be recognizing and protecting rights. Some of those people are building technology. So it won't matter. The answer to this question is what rights we wish to have recognized won't matter. It's the ones that people who are in nations are successfully able to fight for. That's what will matter. And that, again, is what I'm hoping to get all of you to help with, is help with that fight.
All right. Thank you, Paul. Thank you for an entertaining session. We're done today. I'm pretty sure there will be more people who will be wanting to interact with you once our pandemic problems go away. We are quite a bit in the tsunami zone of the pandemic, right?
Yes, things are terrible there in the news.
Yeah.
I wish you the best and the best outcome.
Yeah, and there will be more, and we will probably reach out to you once that subsides. Right.
Let me
And there are
encourage
more
that.
questions around it. Yeah.
Thank you for that. But let me just say, email is great. Talk to me. My email address is in the portal. If you have more questions, you want to have more discussions, I am available. This is what I do. Okay.
Thank you, everyone. Let's reconvene tomorrow for day 2 of the Data Privacy Conference. Thank you. Thank you, everyone, for staying late. Bye.